Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay, for this week we will learn about dual LP or also known as dual problem. Okay, so in the past you have learned LP problem which is known as primal. So primal, the objective function is normally denoted by Z function, and the decision variables are denoted by xi. But for dual, the objective function is denoted by w and decision variables yi. Okay, but dual problem is actually equivalent to the primal problem. If the primal is maximization problem, then dual will be minimization problem. So the opposite. Okay, so general rules for constructing the dual problem from primal. The number of variables in the dual problem is actually equal to the number of constraints in the original problem, or also known as primal. Okay, the number of constraints in the dual is equal to the number of constraints in the original problem. And coefficient of the objective function in the dual problem comes from the right hand side, okay, of the original problem. The right hand side of the dual constraints come from objective function coefficient in the original problem. Okay, let's look at the example. So example 3.11. In order to find the dual of the given LP, so this is original LP problem, or also known as primal. Original LP, or also known as primal. So from here, in order to change to dual LP, you need to convert this LP problem to standard form. So we need to change all these constraints into equations. Okay, so it's going to be like this. Subject to 8x1 plus 6x2 plus x3, because it's less than or equals to, so we add slack, which is s1, right hand side equals to 48. Okay, and then second constraint, 4x1 plus 2x2 plus 3 over 2x3, also plus slack, s2 equals to 20. Third constraint, 2x1 plus 3 over 2x2 plus 1 over 2x3 plus s3 equals to 8. And then we have 3 additional variables here, x1, x2, x3, s1, s2, and s3 must be greater or equals to 0. And the objective function max z equals to 60 x1 plus 30x2 plus 20x3, and then we have slack variables plus 0s1 plus 0s2 plus 0s3. Okay, from here, in order to change to dual LP, to convert this primal problem to dual problem, remember in the previous page, it is already mentioned that number of constraint will be equals to number of variables. Okay, so here, okay, let me change the color. So here, for constraint 1, okay, just put y1 for variable 1, y2 for second variable, and then third constraint for y3 for dual. Okay, and then we'll just put here, it's easier like that, y1, y2 and y3. Okay, so because this primal is maximization, therefore for dual, objective function will be minimization, and all the constraints should be greater or equals to. Okay, so number of variables, here we have number of decision variable equals to 6 for primal. So number of constraints for dual will be 6. So because minimization, then all the constraints will be greater or equals to. So the total constraint should be equals to 6. Okay. And then here, right hand side for dual comes from the coefficient of primal, coefficient for each variable in primal. So the first constraint, right hand side, is 60. Second constraint, 30, 20, 0, 0, 0. So from this coefficient. Okay, so column will become rows, right? So first constraint for dual will come from first column. Okay, so 60, and then 8y1 plus 4y2 plus 2y3. Okay, for the second constraint or row, it will come from second column from primal. Okay, so 6y1 plus 2y2 plus 3/2 y3. For the third constraint, it comes from third column in primal. So for this one, y1 plus 3 over 2 y2 plus 1 over 2 y3 greater or equals to 20. Third coefficient. Okay, and then fourth constraint comes from the fourth column. So here, this one, the coefficient is 1, right? So 1 y1 plus 0 y2 plus 0 y3. So only y1. And then the next column, 0 y1 plus y2 plus 0 y3. So y2. Okay. And the last column, only y3 greater or equals to 0. Okay, for the objective function, for dual, because this primal is maximization, therefore dual will be minimization. W equals to, okay, the coefficient of the first variable will come from right hand side. So 48 y1 plus 20 y2 plus 8 y3. Okay, so from here, these three constraints are actually the lower bound. So yi must be greater than or equals to 0 for I equals to 1, 2, 3. Okay, that's it.